Alright, here is an example using Gay-Lussac's law that I'm going to show you how to set up the calculation. This is on slide 52 of our chapter 11 PowerPoint. So it says, home oxygen tanks can be dangerous if they are heated because they can explode. An oxygen tank has a pressure of 120 atmospheres at a room temperature of 25 degrees Celsius. If the temperature of the gas inside the oxygen tank reaches 402 degrees Celsius, what will be its pressure in atmospheres if the volume and amount of gas do not change? The oxygen tank may rupture if the pressure inside exceeds 180 atmospheres. Would you expect it to rupture? So obviously this is kind of a two-part question. First part, we're going to have to calculate our new pressure of our gas cylinder at a higher temperature, and then we're going to have to determine if it's above or below 180 atmospheres, would we expect our tank to rupture. So this problem is going to be utilizing Gay-Lussac's law, which is relating pressure and temperature, and we can tell that because the only two variables that are changing in our problem are pressure and temperature. So the equation we're going to use is P1 over T1 is equal to P2 over T2. You'll notice pretty much all the gas laws are very similar to one another. They're just variations of one another and how pressure, temperature, volume, and moles all relate. So if we read through the problem again, first part tells us that our P1 is 120 atmospheres. Atmospheres is another unit of pressure. And that our temperature, T1, is 25 degrees Celsius. Then if we read into the second paragraph, we are given a second temperature, so that's T2 of 402 degrees Celsius. And P2, we don't know. That's what we're looking for. That's the variable that we're trying to find out. So just like the last problem that we worked, before we go plugging in on all of our numbers into our equation, we have to change our temperatures into Kelvin. So I'm going to add 273 to each of my temperatures, and that's going to give me 298 Kelvin for my first temperature and 675 Kelvin for my second temperature. So now to complete the rest of the problem, sorry, I'm marking on my page, is to plug into our equation written above. So our P1 is 120 atmospheres, T1 is 298 Kelvin, P2, we don't know it, that's what we're looking for, and T2 is 675 Kelvin. So I'm going to cross multiply, and we're going to have 120 times 675, which should give us 81,000, is equal to 298 Kelvin times P2. Now if I divide both sides by 298, I get that P2 is equal to 272 atmospheres. Now, if you're following along on the PowerPoint, I think they have 270 atmospheres. That's because they rounded a little differently than I did. So then, second part of the question, the oxygen tank may rupture if the pressure inside exceeds 180 atmosphere. Would you expect this temperature to rupture our tank? Well, since our pressure is higher than 180 atmospheres, then I think it's safe to say yes, our tank would rupture. And that's the end of the problem. So 2 things we were looking for are pressure, and yes, our tank would explode if the temperature was brought up to 402 degrees Celsius.